Hi students, this is Alex here. In this video, we are going to find a solution for a given partial differential equation. The question is z is equal to px plus qy plus 3 into pq whole power 1 by 3. So this given equation is in the form of z equal to px plus qy plus a function in terms of p and q. So f of p comma q. So for this, the complete integral is got by taking p as a and q as b. So z equal to ax plus by plus 3ab whole power 1 by 3. Let's keep this as first equation. Here we find the number of arbitrary constants, that is a and b. So two constants are there. That is equal to number of independent variables. There are two variables x and y. So we get the complete integral like this. Now to find the singular solution, we have to take the first equation and differentiate partially with respect to the constant a. Other than a, remaining are treated as constant, so the differentiation becomes 0. Z differentiation is 0. Ax is a is 1, x is a constant as it is, dy is fully constant, so it is 0. Here 3b power 1 by 3 is a constant. We have a power 1 by 3, that differentiation is 1 by 3 a power 1 by 3 minus 1. So this is actually 3 a power 1 by 3 and b power 1 by 3. So we keep the constants separately, differentiate the a using the formula x power n differentiation. X power n is n x power n minus 1. So here we can cancel this 3 and 3 and we can take this x to the other side. So minus x equal to b power 1 by 3 and 1 by 3 minus 1 after taking LCM, it is minus 2 by 3. So a power minus 2 by 3. So we keep this separately. Now differentiation of 1 partially with respect to the constant b. So z differentiation is 0, ax is fully 0, b is 1, y is written as it is. Now 3a power 1 by 3 is kept as it is, and the differentiation of b power 1 by 3 is 1 by 3, b power 1 by 3 minus 1 is minus 2 by 3. Again we can cancel this and take y to the other side. Minus y is equal to a power 1 by 3 and b power minus 2 by 3. So we got x and y like this. Now I have to substitute in first equation. So on substitution we get z in terms of a and b, and that we have to replace again in terms of x and y. So z is equal to ax. So a into x. This is minus x. So it will become minus b power 1 by 3 a power minus 2 by 3 plus by, and this is minus y, so I have to take the minus to the other side. A power 1 by 3 b power minus 2 by 3 plus 3 a power 1 by 3 b power 1 by 3. So we take a power 1 by 3 b power 1 by 3 as it is. Now totally we get z equal to minus, this is power 1. So this is power 1 and this is power minus 2 by 3. When I combine 1 minus 2 by 3, 3 minus 2, 1. So power will be 1 by 3. So first term is a power 1 by 3 and b power 1 by 3. Second term is again combining the power of b, we get minus a power 1 by 3, b power 1 by 3. And the last term is 3a power 1 by 3, b power 1 by 3. Totally this is 3 minus 1 is 2, 2 minus 1 is 1. So z is equal to a power 1 by 3, b power 1 by 3. This I have to replace in terms of x and y. For that, we are going to make a product of minus x and minus y. So from the expression which we already got, minus x into minus y is, minus x is b power 1 by 3, a power minus 2 by 3. Into minus y is a power 1 by 3 and b power minus 2 by 3. Now combining this, 1 by 3 minus 2 by 3 will be minus 1 by 3 and b power 1 by 3 minus 2 by 3 minus 1 by 3. This is x, y. Now we can take this as a power 1 by 3, b power 1 by 3, and it is better to take the reciprocal, so we can get the answer easily. Xy equal to, we take to the denominator, a power 1 by 3, b power 1 by 3. Now by cross multiplication, a power 1 by 3, b power 1 by 3 will become 1 by xy. So this value is replaced as 1 by xy. So z equal to 1 by xy, and by cross multiplication we get x, y, z is equal to 1. This is our singular solution. To get the general solution, we have to take z, which is ax plus by plus 3 a power 1 by 3 b power 1 by 3. Replace b as a function of a. So z equal to ax plus phi of a into y plus 3a power 1 by 3 phi of a whole power 1 by 3. So we replaced b as phi of a. Now let's take this as our second equation, and we are going to differentiate second equation partially with respect to a. So this is 0, a will be 1 and x is a constant as it is. Phi of a will become phi dash of a and y is a constant as it is. Here we have power 1 by 3 for a and phi of a. This can be rewritten as 3 into a phi of a whole power 1 by 3. So if we take this expression, 3 is a constant, the whole power 1 by 3 is 1 by 3, then a into phi of a whole power 1 by 3 minus 1 into, and we have to do product rule for this. Here one is u, other is v. So a differentiation is 1, phi of a is written as it is, plus a is written as it is, phi of a differentiation is phi dash of a, and we can cancel these two. Now let's take this as the third equation. Now from this eliminating a, from 2 and 3, eliminating a, we get general solution.